Okay, so now let us look at one integral problem related with the trig geometric functions. So the problem we have today is integral, sine cube x times cosine square x and then dx. Okay, so as we can see here, the power of the sine term is 3, and then for the power of the cosine term is 2 here, and also here, okay, 3 is a odd number, 2 even number. Okay, we know that. So, if this is the case, especially you have sine raised to a certain power multiply cosine raised to a certain power, as long as there is a power which is an odd number in our problem, which is the 3. So what we can do is we're going to split those odd number to an even number plus 1. In other words, you can see that 3 equals 2 plus 1. Okay. So why we do that, I'm going to explain in a minute. So if we do that, you see we have sine square x times sine x, and then times cosine square of x dx here. Okay. So first, find the odd power part, split it into even number plus 1, which is very easy to handle. And after that, you're going to need to use one of the identities about the trig, which is sine square plus cosine square equals 1. And correspondingly, sine square x equals 1 minus cosine square. And cosine square equals 1 minus sine square. Okay. So now we still focus on the sine part, which is the part originally have the odd power. So I rewrite it into sine squared times sine x. Now, what I want to do is, I want to use the identity here to convert this part in terms of cosine. So that is 1 minus cosine square x times sine x times cosine square x dx. And then if I reorganize the order of this integral, now says is pretty clear why we want to have this format, because up to now we can use the u substitution. So u substitution. If we set u equals cosine of x, and then du can be negative sine x dx, and look at what we have here. Do you realize that we have sine x dx here, right? So then du equals negative sine x dx. So we can easily find sine x dx equals negative du. So after we do a u substitution, it turns out we have 1 minus u squared, right? And then times u squared, and then times negative du. Okay. And it turns out this can be, I can factor this negative to here. It comes into u squared minus 1 times u squared du. That is u to the power of 4 minus u squared du. Okay. And it turns out this integral is very easy to evaluate as u5 over 5, right, minus u cubed over 3 plus constancy. Of course, our final answer, we have to substitute u back with cosine. So the cosine to the power of 5 over 5 minus cosine cubed over 3 plus constancy. Okay, so that completes our problem. So as you can see, let me briefly go through this again. The original problem is a sine cube times cosine squared dx. Like we mentioned, we located the term with the odd power and then rewrite it into an even power plus 1. In this case, which is 3 plus 1 here. And then this is what we get, sine squared times sine times cosine squared dx. Still, we want to use one of the identities to convert my sine squared into 1 minus cosine squared. And then, turns out, this is the ideal form. And why we want to do that? Because, as you can see, that all the term inside this integral is about a cosine except one term here, and then dx. And why we want this? Because this is a perfect format to apply the u substitution. Because if you apply the u equals cosine x, du equals negative sine x dx. So we can apply the u substitution very easily. And more generally, here guys, so the general case, okay, so if you have the integral sine raised to the power times cosine raised to the nth power dx here, and as long as m or n is odd, okay, and then so for example then rewrite, let's see, m is odd, okay, without loss of the generality. Rewrite m equals 2 times k plus 1. K is a positive integer, okay, and then you can rewrite your integral into sine to the power 2k x times sine x times cosine to the power of nx dx, and then you can write this as sine squared raised to the power of k times sine x times cosine to the power of n dx. And then of course you can use one of the identities to rewrite this. Going to be 1 minus cosine squared to the power of k times sine x times cosine to the power of n dx here. And of course you see here, let me put some blocks here. Okay. So we're talking about the general case. And then your integral is going to become into 1 minus cosine squared to the power of k times cosine to the power of nx times sine x dx. And like we said, starting from here, use u substitution. That is set u equals cosine x, and then du equals negative sine x dx. Okay, and then you can convert this problem into integral 1 minus u squared to the power of k times u to the power of n, and then negative du. Okay, so this integral is pretty easy to evaluate it, because no matter what, the final expression for this, it's going to be a polynomial type. So you can easily to integrate this part and then substitute it back, then it will solve the problem. Okay, so this is a type of questions in this form, integral sine to the power of m cosine to the power of n dx. In our problem here, as you can see, that m equals 3, n equals 2. Okay, so hope this can make things a little bit clear. I'll stop here, and thank you for watching this video.